Welcome to your multi-view sketching video tutorial lesson. Multi-view drawing shows two or more two-dimensional views of a three-dimensional object, provides a shape description of an object. When combined with dimensions, it serves as the main form of communication between designers and manufacturers. Here's an example of a multi-view sketch. It's a dining chair. You'll recognize this view. This is an isometric view here, and these are the multi-views of that same isometric sketch. So we have the front, the top, the right side, and the left side of this chair. Here's a different example of a multi-view drawing. This one contains dimensions, and you see those dimensions with the extension lines, and you also notice there's hidden lines. Those hidden lines represent the surfaces that we can't see in certain views, but we can in the top view. All three-dimensional objects have width, height, and depth. Width is associated with an object's side-to-side dimension. Height is associated with an object's top-to-bottom dimension. Depth is associated with an object's front-to-back dimension. Let's look at this example of a multi-view drawing and this part. So this is a typical multi-view drawing, and it includes a top view, front view, and right side view. Here we have the front of the object, the top, and the right side. So if you were to draw the top view, it would look like that. Imagine moving the part so that you would see it as the front view, just like the animation just showed us. And then imagine doing the same thing for the right side. You're just moving it so that you can see the right side. This is a multi-view drawing at its most basic form. Here we see the height, width, and depth of the part. So the isometric view shows the width, height, and depth of the object. The height of the object is obvious in the front view and the right side view. The width is displayed in the front view and the top view, and the depth is shown in the top and right side. Notice how all views are aligned such that they line up. Construction lines can be used to help project the views from the first view drawn. So let's look at that. So the height of the part, you can see the height of the part. These would be the construction lines. On the right side, it's the same exact height. So when you start to draw your multi-view drawings, make sure that the height is the same on the front view as the side view. And you have to also do the same with the width. So whatever the width is in the front view, it needs to match in the top view. For depth, you can draw construction lines, a 45-degree angle, and then you would get your depth. The depth in the top view and side view need to be the same. This is called orthographic projection. It's a technique used to create multi-view drawings. Any projection of the features of an object onto an imaginary plane of a projection. The projection of the features of the object is made by lines of sight that are perpendicular to the plane of the feature. So let's look at an example. So the best way to understand this orthographic projection is to imagine that the object is contained inside of a glass box. So let's put this object in a glass box. With any box, there's 6 walls. This glass box has 6 glass walls surrounding the object. Each wall represents a projection plane. So this front wall right here is a projection plane. We can project the front view of that object onto this projection plane to get the outline, the object lines that we need for the front view drawing. This is also referred to as a picture plane or plane of projection. It's the imaginary surface that exists between the viewer and the object. It's the surface onto which a 2D drawing of a 3D object is projected and created. So let's start by focusing only on the front projection plane. So we're only looking at the front glass box, the front of it. So if you're standing in front of this object, you would see only the 5 corners identified in the back. 1, 2, 3, 4, 5. Projection lines are used to project each corner outward until they reach the projection plane. An imaginary line that is used to a projection line is an imaginary line that is used to locate or project the corners, edges, and features of a three-dimensional object onto an imaginary two-dimensional surface. The visible edges of the object are then identified on the projection plane by connecting the projected corners with object lines. You would draw your object lines like shown. The orthographic projection process is then repeated on the other projection planes. So here we have an example of a part. Here's the front view, and if we were to imagine looking at the top would look like this, the right side would look like that, the left would look like that with your hidden lines. You can see the hidden lines here showing the other surfaces behind these parts. So there are 6 principal planes as indicated here. In most cases, 3 or fewer orthographic projections are needed in a multi-view in order to fully describe an object. Most of our multi-view drawings will only have 3 views: the front, top, and right side. So when you are selecting a view, here are the recommendations. Find the most natural position of the object, whatever shows the best shape and characteristic contours. Typically the longest dimension will be the front view. Also the view with the fewest hidden lines and or the most stable and natural position of the object. So in this example, the front view choice dictates the pictorial orientation as well as the orthographic projection labels. So if you were to select the best front view, you might say that this is the best front view because it has the longest dimension, has the best shape description, there's no hidden edges, and it looks like it's in its most natural position. There are a number of orthographic projections. So only one view may be required if the part has a uniform thickness, such as a flat plate, or a uniform shape, such as a cylindrical shape. If 2 views would be identical and all dimensions are easily shown in one view, additional views may not be necessary. All dimensions properly and easily shown on one view are necessary in order to create that part. So there are a number of orthographic projections. Here we have 2 views. This is a symmetrical part. A third view would be identical to one another. So a second view is necessary for the depth. So we didn't need a third view in this example here. Alright, so let's look at this part here. Given the overall dimensions of the object, you'll need a pencil, a sheet of paper, and multi-view drawing paper or grid paper. And you can easily draw a multi-view drawing by using points, construction lines, and object lines. So grab a sheet of multi-view drawing paper and continue with step 1 here. Step 1 is to lay out the boxes within which the individual views will occur using points and construction lines. Once you have this laid out, label the top, front, right side. You'll use construction lines between the views to indicate the geometry of the views. The line just drawn is that surface where it's being pointed from, and so on. So we've identified the visible edges, and now we can draw our object lines. For step 4, we're going to locate the hidden lines. This is the hidden line. This represents this surface right here. This hidden line right here represents this inside surface on the inside of the part. Here's a historical example by Leonard P. Carr. This is a design. He designed a man-sized hunting blind shaped like a goose called the Super Goose in 1991. So you can see, I don't know if you can tell, there was a man that would sit inside a goose. So how would you label the views represented in the drawing? This would be the front, the bottom, and a right side. Are Mr. Carr's views properly aligned based on the orientation presented here? And how would you rearrange the views? Let's also look at these blocks. Each of the blocks to the right has the same dimensions and color. What else do they have in common? Each of the blocks at right has the same overall dimensions. And they all have identical tops. What you'll need next is a pencil, a ruler, and a puzzle part. If you don't have this puzzle part in front of you, that's okay. Just follow along with what I draw on the multi-view sheet of paper. Okay, so we're going to make a multi-view sketch of this part. This is going to be one of the simplest multi-view drawings that you can make. So we're going to do a so every cube on here on this part is going to be 3 units on the grid. So it'll be 3 by 3. So let's start off by making the isometric view of this part. Okay, so isometric, if you were to look at an isometric, just hold it in front of you so that it looks like that to get an idea of how you're going to start that. And then on your isometric paper part of your multi-view, find a spot near the top and let's make a couple dots. So 1, 2, 3, 1, 2, 3, 1, 2, 3, and you're gonna use your ruler to draw the top of that object. Okay. And then you're gonna go down 6 on this side. So 1, 2, 3, 4, 5, 6. You're gonna go over 6 because it's 3 and 3. So 1, 2, 3, 1, 2, 3. I like to put dots on my isometric grids so that I can find a place. It's like connecting the dots. You're gonna go up 3, 1, 2, 3, over 3 from there, and then close this side. So I don't know if you can already tell that this side right here is formed here. So let's finish the top. So we're just going down 3 at a time, connecting our corners. We can then draw 1 here and 1 here. So 1, 2, 3. And from this corner section here, 1, 2, 3. And then just close those up. So this is that's the isometric drawing of this part. I'm going to go ahead and shade the sides. And now I'm going to start by selecting the front view of the part. This is the best front view. It shows the most detail, has longest edge, and I feel like this shape is like an L, so it just would be more, it's in a more natural position. So I need to start by drawing a very light line. So find the A and go a few blocks under the A. I like to draw, so like if you see the name part right here, there's this like thick line. If you go up like 3 cubes and over 3, so that's 1, 2, 3. So like right here is a good starting point for most of your multi-view drawings. Sometimes you might need to go up 2, over 2. But what you need to draw is a construction line. And construction lines are drawn very light. So a super light line, you can barely see it on the camera. And you want to do the same going vertically from that point. And you're drawing directly on the grid lines, these very light construction lines. Now we said that each cube here is 3 units. So that means I need to go 1, 2, 3, 1, 2, 3. That's 6 units up from this corner to get the height. And then the width will also be 6. This height right here is going to be 3. So from here up, I'm going to go 1, 2, 3, 4, 5, 6. There's my height. I will then draw a construction line all the way across like that. My width is also 6, so 1, 2, 3, 4, 5, 6. Let's move that over. And again, a nice straight construction line, really light, enough that you can see it, but you can't really see it from far away. And then I like to separate my top view about 4 units up. So from the top line here, go 1, 2, 3, 4. And draw a horizontal construction line all the way across, like that. If I were to flip this up like so, there's my top view. Each cube is 3 units in depth. So that means that this construction line is going to go up 3. So I'm going to draw a construction line that is 3 away from this one. The side view is, so here's the front, here's the top, front. The side view is going to look like that. That's also going to be about 1, 2, 3, 4. Let's make it 5 units away from that line. Draw a construction line, go over 3, draw another vertical construction line. Okay. This cube here is going up 3 from this spot. And let's just go ahead and start drawing some object lines so we can start to see this pop out. I'm going to use something a little darker so that you can see, but you're only going to use pencil in the class. I don't want you using pens until you're much more advanced with these drawings. So it's 6 tall. So the height is 6, the width is 6. This block right here is going up 3. Just like that. It's going to go over 3. So from that point, go over 3. Always use a ruler. You're going to go up 3. And then you're just going to close the part. So there's your front view of this block. You can label that front. And always write in all caps on your multi-view drawings. Now, everything's lined up. So the bottom of the part and of the front view of the part and the side view here, they need to be on the same drawing line. So I'm going to draw a line. The height has got to be on the same, it's got to match, it's got to be the same height. just like that. So we should have a rectangle that is 3 by 6. Now this surface right here, that gets projected over. So line up your ruler and draw a line right there. So that line that you just drew is this surface. So if I were to label this surface A, that means that this surface right here is A. It also means that this surface right here is A. Let's draw the top view now. So the top view is like you're looking at the part from the top view if you're a bird looking up over something. That's also a 3 by 6 rectangle. And then again, this edge right here gets shifted up. So line up your ruler, draw the edge. And can you tell me where surface A is on the top view? It's right here. So that's A. If I were to label this surface B, where would B be on the front view? It would be here. B. Where would B be on the side view? Let's label this side view. And let's label this top. B would be here. Where's B on the top view? Here. If we were to label the front C, where is C on my multi-view part of my drawing? C is here. C is also here and here. If I put a D here, this is D, this is D, this is D. So hopefully by this point you understand the basic concepts of drawing a multi-view drawing. You have an isometric view of the part, you have the front, the top, and a side view of the part. All of the parts are aligned, so if you drew your part and it's like shifted up, that's incorrect. Same thing with the top view. If you have your back edge here aligned, that's correct, but if it's shifted over, that's wrong. So if this is 6 wide, it needs to be 6 wide in the top. If it's 6 tall, it needs to be 6 tall on the side. So get this drawing done, label it as you see here, write your name, give it a title. This is a multi-view practice drawing, and date it. Make sure I see it, and I'll make any corrections if necessary.